Chapter 4. Congruent figures. And we'll get into congruent triangles. Will be the main topic, but we'll deal with congruent figures. Alright, so when we're dealing with congruent polygons, basically a polygon is a many-sided figure. So we have triangles, we have rectangles, we have quadrilaterals, we got pentagons, we got hexagons, we got all different types of polygons. When we're dealing with congruent polygons have corresponding congruent parts. So that means their corresponding sides are congruent and their corresponding angles are congruent. So if we're talking about a quadrilateral, alright, so these two quadrilaterals here, they are congruent because all their corresponding sides are congruent. Take for instance, angle C corresponds to angle Y, congruent, angle B to angle Z, angle A to angle W, and D to angle X. They are all congruent. So we need to make sure that when we write the congruent statement, that we have all the parts match up. All the parts match up. Quadrilateral symbol is just a quadrilateral. Alright, so if we take A, B, C, and D, congruent to the next, I gotta make sure whatever corresponds to A goes first. And A has 3 marks, so that's W. Whatever corresponds to B goes next, that is Z. Whatever corresponds to C goes next, that's Y. And whatever corresponds to D goes next, and that's X. And that is the way you need to write the corresponding or the congruent statement. All the corresponding parts are matched up. So that if I didn't have a diagram at all, and I just have this, I know that angle A is congruent to angle W, angle B is congruent to angle Z, angle C is congruent to angle Y, and angle D is congruent to angle X. I also know that AB is congruent to WZ. AB, WZ. I also know that BC is congruent to ZY. BC congruent to ZY. I know that CD is congruent to YX. Here's CD, and here's YX. And then I know that AD is congruent to WX. AD, WX. So that we have them all matched up. So we don't need a diagram to be able to tell what my corresponding parts are. And congruent polygons, corresponding angles and corresponding sides are congruent. That is the definition of corresponding polygons. Corresponding polygons are polygons that have corresponding angles and corresponding sides congruent. Alright? Corresponding polygons are polygons that have corresponding parts congruent. Take for instance, if I had a triangle HLM congruent to triangle POQ. My statement says that they are congruent because corresponding polygons definition says corresponding parts are congruent, I know that angle H is congruent to angle P. I know that angle L is congruent to angle O. I know that angle M is congruent to angle Q. I know that HL is congruent to PO. I know that LM is congruent to OQ. And I know that HM is congruent to PQ. So even the corresponding letters match up. The first letter is to the first letter, the second letter to the second letter, third letter is to the third letter, the first two is to the first two, the second and the third is to the second and the third, and the first and the third is to the first and the third. They all matched up. If I have a triangle, I have 6 corresponding parts. If I have a quadrilateral, I have 8 corresponding parts. If I had a pentagon, or congruent pentagons, then I would have 10 corresponding parts that are congruent. So my corresponding parts are congruent, and I need to make sure that my statement is written correctly. Common mistake of geometry students is not making sure that their corresponding parts are written in order or in the corresponding parts. Alright, so here's my diagram. I have congruent triangles. So I need to write my congruent statement correctly. Now it doesn't matter which one you write first. Doesn't matter if I name the triangle FGI or IFG or GIF. They are all the same triangle. So it doesn't matter how you write them. So everybody's congruent statement could look different, but everybody's congruent statement would have corresponding parts in the right place. So, give me a name for this triangle. Stephanie?
IFG, triangle IFG.
What's that?
Triangle IFG.
Alright, so give me the next triangle with the corresponding parts lined up. What do you think, Kiara? We got triangle IFG, so what triangle is congruent to that?
Triangle SQR.
Does everybody agree? Alright, so I matches up with S, F matches up with Q, and G matches up with R. So that is correct. So it doesn't matter how we write it, as long as the corresponding parts are matched up. Definition of congruent figures, or congruent polygons. Anybody have any questions on that? Alright, the next definition, or theorem, third angles theorem. Third angles theorem. It says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. Alright, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So therefore, if I have if I have W is congruent to X, V is congruent to Y, two angles of one triangle congruent to two angles of another triangle, what's my conclusion? U is congruent to Z because of third angle theorem. Two angles of one triangle congruent to two angles of another triangle, then the angles, or the third angles, are congruent. Makes sense, because what do we know about a triangle? All the angles add up to? The major angle W plus the major angle V equal, plus the measure of angle U equals 180. And then I know the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180. Because I know that the angles of a triangle add up to equal 180. And now I can say that they're all equal to each other. Measure of angle W plus the measure of angle V plus the measure of angle U equals the measure of angle X plus the measure of angle Y plus the measure of angle Z. Well, I already know that U, or W, is congruent to X, so I can substitute. Measure of angle X. I know V is congruent to Y, so I can put plus the measure of angle Y plus the measure of angle U, measure of angle X plus the measure of angle Y plus the measure of angle Z. By substitution, that would be after I make them equal. And then by subtraction property, I can subtract this and subtract this. And I would have the measure of angle U equals the measure of angle Z, which proves that theorem, the third angle theorem. And so that's the thought process of proving that theorem and using that. So let's look at page 221. Page 221. Everybody look at page 221. Number one, complete the following statements. We got triangle QXR is congruent to triangle NYC. Alright, so segment QX is congruent to Alexander. We're on page 221. Everybody there, page 221. Segment QX is congruent to
NY.
what's that?
NY.
Make sure you write segment NY, so don't forget about the segment symbol. Letter B, angle Y is congruent to Elon? Alright, make sure you write the angle symbol there, angle X, so make sure you state it when you say it. Alright, number two, triangle BAT is congruent to angle, or triangle FOR, so segment TA is congruent to what, Lauren?
Segment R.
Okay. And angle R is congruent to what angle, Stephanie?
Angle T.
Alright, and then we got band is congruent to luck, so angle U is congruent to, and then segment DB is congruent to, Caleb?
Segment KL.
And NDBA is congruent to, Aaron?
CKLU.
Alright, very good. Alright, flip over the page to page 22. We got triangle LMC is congruent to triangle BJK. So therefore, Kiera, what is congruent to LC? Segment LC.
Segment BK.
Number 12, Schuyler, segment JB.
Segment MC. Segment ML.
Say that again.
Segment ML.
Which one number are you on? Number 12?
Yeah.
So segment JB.
Is it ML? Is it flipped?
Yes, ML. Okay, I'm sorry. Yes. They said something different first time. All right. All right, have a good night.